Hello guys, so today we are solving this problem, largest color value in a directed graph. So there is a directed graph of n colored nodes and m edges. Okay, the nodes are numbered from 0 to n minus 1 and we are given a string color like we are given here. Na? We can take this example. So when a string is given, so these ABC like this, these are anchoring for some color code. You can consider like that. So this kind of a string is given to us for every edge. For example, at 0th node, this is A. That means this guy 0, this reddish color is actually a code A. Okay, so in that way it is given to us. Now, what we have to do is, the colors where colors I is a lowercase English letter representing the color of ith node in this graph. So you are also given a 2D array edge. Okay, so we are given a 2D array edge like this, where this indicates that from 0 to 1 there is a node, there is an edge. From 0 to 2 also there is an edge. From 2 to 3 there is an edge. So this is edge array given to us. Okay. So a valid path in a graph is a sequence of nodes such that there is a directed edge from xi to xi plus 1 like this. Okay, for example, you can say here, if we start from 0, so start from 0, 2, 3, 4. Okay, this is a valid node because there is a node from 0 to 2, then 2 to 3, 3 to 4. But from 1 to 0 is not a valid node. Okay, valid path. From 4 to 3, 3 to 2, this is not a valid path. Obviously, this is like. Okay, so what we have to do is the color value of the path is given the number of nodes that are colored the most frequently occurring color along that path. Okay, so what we have to find is return the largest color value of any valid path. For example, if we take an example of this graph, okay, so see here we can either start from 0 or from 3 because there is no edge coming to 0 or 3. So let's say we start from 0, what will happen? Okay, so if we start from 0, this is green, so green came one time, then this is red. Okay, then red came one time, this is blue, then green came again, so 2 times green, 3 times green, this is blue, then 4 times green. So there is total 4 nodes we can see here. Okay, so if we go through this path, if we traverse through this path which is a valid path, we can find there are 4 green nodes. Okay, so we have found 4. Now let's say if we are traversing through this path, red came 2 times, then green came 3 times. Okay, so in this way also green is the winner. So we have to find any valid path. So if there is any valid path, and in that valid path whoever color is came most frequently, that should be the answer. So all valid path and then the highest frequency of a color, that should be our answer. But there is one more condition given in the question, and the condition is return the any valid path in the given graph. So if there is any cycle in the graph, in that case we have to return -1. For example, in this code itself, let's say there was another path from 9 to 3, let's say like this, then there is a graph, and in case of graph we have to immediately return -1. Doesn't matter where this graph is. If let's say from 1 to 1 node there is a self graph, self path, then this is a cycle. In that case also we have to return -1. So what I mean to say is, in this entire graph, if we found anywhere any cycle, in that case we have to immediately return -1. Otherwise we have to find a valid path which has the, so whoever is the valid path and the one where is the highest frequency of the color, that should be our answer. Like in this case, this path having the green came 4 times, so 4 should be our answer. This is what we have to do. So in this graph, so how to do, that is the next thing, how to do. So we can observe one thing here, that whenever we are traversing to any node, let's say we reached till here, so there would be like 26 character possibility, right? We know there are no 26 colors, but for the question's sake they have given, if you go down, you can see here the colors consist of lowercase English letters, and English letters are 26. That means there could be 26 different codes, right? So for every node we have to check that how many times, if some path is coming till here, how many times all the 26 code has been occurred. So what we have to do, for that reason we have to keep a and you can say an array of the 26 character for every node, that how many times one particular color occurred so far. Okay, so our approach would be, first of all we have to go in that way that we are traversing through all the valid paths. Okay, and together we have to also keep track of all the 26 character code, that till this node how many times this has come from all possibilities. Okay, so for that reason what we will do, we will use topological sorting plus dynamic programming. I mean one just the DP of 26 size, right, for every node, and we have U node. In that case we have to we have to have a 2D DP array, right, of the having 26 columns, and the total number of nodes, whatever is the number of node, that would be its size. So what we will do here is we have to create a DP array, and then we will go in the topological sorting way. So what all things we will be required here is one DP array where U is the total number of nodes in that graph. So this is U, and this is 26 character color code. Okay, so we will maintain this DP array, and then we will use the topological sorting. What I mean to say in topological sorting, if you don't know, I have put the link in the description box, you can read about it. Topological sorting is nothing but just to find the cycle in a graph. So what we do is, so in topological sorting we start from the in degree 0 nodes. Okay, so in this case what is the in degree 0 node? 0th node, this guy is in degree 0, right? So we can start from here, or this guy also having in degree 0, because there is no edge coming to this node 3 or 0. So these could be the start point, but others are having in degree, for example 4 has in degree 1, because at least one arrow is coming to it, so we cannot start. So we can start either from 3 or we can start from 0. So what we will have first of all is we will make a adjacency list of this graph. So you know the adjacency list of the graph is like a 2D array where we have the list of nodes which are directly connected to a given node. So we will create one adjacency list of it, then we will create a in degree array of it, right? So in degree is like the degree, how many nodes are coming to that particular node. For example, 3 has in degree 0, 4 has in degree 1, 0 has in degree 0, right? See here, this node 2 has in degree 2, because 2 nodes are coming to it. Okay, so same way we will create an array of in degree. We will have an adjacency list, and then we will have few other things like priority. One queue also we will use in this to park the values. So we use a queue in the topological sorting. Okay, so what would be the whole idea here is we would be starting from here, right? Let's say from 0 and 3. So initially what will happen in the priority queue, let's say this is our priority queue. In the priority queue initially 3 and 0 would be there, because all the guys who are having in degree 0, those would be entered to the priority queue. Then we will pick them out one by one. So let's say if we remove 0 from the priority queue, in that case we have to update the in degree of all remaining parts. So what will happen if we remove this 0? If we remove this 0, this arrow would be removed. So if we remove this arrow, this guy, this node 1 would be having the in degree 0. So next time we would put this guy 1 into the priority queue. Okay, then we will again look into the priority queue, and then we will pop out this guy, right? So whenever we are popping out any node from the priority queue, we have to update the in degree. For example, if we remove the 1 also in the priority queue, in that case the in degree of 2 would be affected. As of now in degree of node 2 is 2, but once we remove this guy, its in degree would become 1, because only one in degree is coming to it. So in that way what we are doing, we will keep on removing the guys from the priority queue and update the in degree. At the same time we will keep in this DP array, we will keep that what all colors has been occurred so far, and we would update all of them. Okay, so we will look into the code which will make this, whatever I am saying, a better sense. Okay, so this is my code. So see here, first of all, what I'm doing, I'm getting the length of how many nodes are there. Okay, so whatever is the colors they are providing, that length would be the equal to total number of nodes. Okay, now see here, I'm just creating one in degree array of the length n, and then here I am creating the adjacency list, where every graph has a adjacency list. So what we are doing here is, I'm just for this adjacency list, I'm putting initially the empty array list, because every node would be having some values connected to it. And this is my dynamic DP array, which I created the whatever number of nodes, and 26 would be the color code. Now this is my priority queue. So a priority queue initially it is null. Now see here what we are doing. We are putting the we are filling the adjacency list, that for adds array we are going. So in adds we have 2D things, right? You can see here, these are our adds. Okay, if you take this example, so 0 to 1 is adds, 0 to 2 is there is an edge. So for sake that I am creating this adjacency list. Okay, so for 0th node, whoever is connected to it, that would be the second value here. So for example, 0 to 1 it would be connected, 0 to 2 it would be connected. So at the same time you can see here the second value in degree also I am updating in the same loop. So in degree of the second value, the one which for which the edge is coming, I am increasing those in degrees as well in the same for loop. So I am updating the in degrees as well. Now what I am doing after doing this all till here, what I'm doing, I'm checking that who all nodes have the in degree equal to 0. So whoever has the in degree equal to 0, I'm pushing them to the priority queue, just like in this case in degree. So this guy 0th node and 3rd node, 3 node, both of them has in degree 0. So initially 0 and 3 would be into the priority queue, like this, 0 and 3 they will go to priority queue first, because they have in degree 0. So we can start from there. Now these are two variables just in scene and answer, which will be park our final answer. Now see here what I am doing, till the time when priority queue is not null, I'm popping out the elements. Okay, and then just increasing the scene value plus plus, that we have visited one node. So whenever we are popping out a node, we are increasing this scene variable. Now see here what I'm doing, I'm taking out the code. Okay, so in the colors we have the node of we have the color code of it. For example, see here, this is a color string. So whoever is node 0 has A, right? So if we do the A minus character A, then we will get the corresponding index in the 26th thing. Okay, in the 26 locations. So we are extracting here colors code, and for that whatever node we have popped out, for that node we are increasing the frequency of that color. Okay, so in DP array, for this is the node which pop out from the priority queue, and this color code of it. So we are increasing it. Okay, so we are increasing it every time. So guys, you can visualize here. So for example, this is our DP. Okay, this is of whatever is the number of node, and whatever the 26 is the character. So let's say this is our priority queue. So initially our priority queue would be having all those nodes which has the 0 in degree. Okay, so 0th node and the 3 node, these guys have 0 in degree. So let's say they are in the priority queue like this, 0 and 3. These nodes are in the priority queue. So we will pop out first of all any one of them. So let's say 0 is coming out of it. Of 0, what we will do is we will go to this DP table. Okay, and we will look into this color, that 0th node, what is the color code. So see here, color code for 0th node, which is green, is A. Okay, so what would the equivalent coordinate of A? It would be 0th, right? So at that node we will first of all increase the frequency by 1. Initially everything is 0, so we will increase this guy by 1. Okay, so we have increased because this green color has occurred. So we have increased frequency of this node, 0th node, and the A coordinate. So A is coming very fast. Now when we have popped it out, now we'll go to this guy. So we would be removing by this guy. Okay, so once we will remove this guy, our coordinate, we have to update our in degree as well, because this part we are removing. Okay, once we will remove this 0, we have popped it out. Now who is the new in degree having 0, 1? Right? So 1 is the node which has the in degree 0 now. So we will push this also into the priority queue. Okay, now before going to this, the 0 we have increased its count by 1 at the corresponding color code A. At the same time, like 1 was connected to it, so we have to look that what is the frequency of all those characters of the node 1 before popping it out. So we will check for all these values and we will keep who is the maximum out of this parent node and the current value. So 0 was the parent here and 1 is the currently exploring value. So we have to update all these 26 values with the maximum of these two, means the 0th and 1st node, whoever came next time, that we have to update every time. Okay, so why we need to do it? Because for any node we might reaching from different paths, right? And we are interested to get the maximum value, so we have to update the maximum frequency. For example, let's say we are at this 0th node, this 2 node, so we have this path as well, right? We have this another path as well, so we have to keep the maximum value updated here. For example, red color by this path, if we are traversing through this path, red color came only one time, but if we are traversing through this path, red color came 2 times. So we have to update the best value so far occurred for every color. We have 26 colors, right? For every value we have to update the maximum frequency. That is why we have to update and keep the maximum value in the current node. Okay, so in this way we will go for all of them. So you can visualize here in the code. So as soon as we are popping out the value, like u be popped out from the priority queue, then we extract the coordinate of the color and we increased it directly. Okay, so for that coordinate we have increased dpu c++. Now see here, I am looking for the answer as well, that whatever value occurred so far I am taking the maximum of that, because we will traverse to every node, right? Now see here, when we popped out this node u, okay, we are looking for the adjacency list of it. Okay, whoever is connected directly to it. Like in this case, when we removed 0th node, 1 was directly connected to it. That is why, for that reason, I checked here that, hey, what is the maximum so far occurred value for every frequency. Okay, so for that reason what I am doing here is, we are going for all the 26 locations and then we are making the maximum value. So see here, dpvk, right, the connected value from the parent u. So what I am doing here is dpvk, I am taking the maximum, whoever is maximum, either dpvk or dpuk, because we are interested to take the maximum till reached for that particular node. Let's say in this example, till reaching this, who all came maximum time, all those colors, because regardless of which path we have chosen, we have to keep track of the maximum frequency occurred so far. Doesn't matter it is coming from which path. Okay, so for that reason I am doing. So here I am updating the maximum value to all of them. And see here, again whenever we updated it, right, we are decreasing the in degree value. Like in this example, as soon as I removed this guy 0, we decrease the in degree of 1 because it is directly connected. So for that reason what I am doing, I am decreasing in degree v minus minus, right? So we decrease it by 1 and then we are updating the maximum value color code frequency for this v. Now see here, I am again checking that, hey, whoever has the in degree v equal to 0 now, they also should go to the priority queue. For same reason what I did, when we removed this guy, our new in degree, the in degree of this guy became 0. So that is why this node 1 also was pushed to the priority queue. So I have pushed it to the priority queue, right? So we are so in this way what will happen, we will traverse for all the valid paths, right? And when we will come out of it, see here we are checking that if scene equal to n, that means we have popped out all the elements. Okay, then we are returning the answer. But if scene is not equal to n, that means there would be some cycle, because in case of cycle our in degree would never become 0, at least for one node. For example, let's say there was a something like this, there was a self node. So even if I decrease the in degree, Here it would be decreased, but for self node this is considered a cycle. So this will keep on remaining in this priority queue always, because its in degree will never become 0. For example, let's say if cycle was there itself like this. Okay, so even if we are traversing through, the scene number would never decrease, because this guy would be always connected to 3, then this guy has always these connected values. So we will be never able to come out of this priority queue equal to empty. So for that reason, if this scene is not equal to n, that means all the characters, all the nodes has been popped out, then we are making answer as written. Otherwise we are returning -1, because in that case it represents a cycle. So let me execute this code, which I have already executed, but again I am for the sake of video, and let me submit it. So yes, it is 97.73 faster. So what is the time complexity here? Time complexity is if there are n total number of nodes, okay, and for every edge also we are traversing, so this would be m plus n. So you can say order of n is the time complexity, and definitely we are taking the extra space, which is again the order of n only. So thank you for watching this video, and if you guys have any concern, please make a comment over there. Thank you.